Hello and welcome to my channel. In this series I take you through past VCAA Maths Methods exam questions and provide you with full work solutions. In today's video we'll be going through question 5 and question 6 of the 2020 exam 2, so that's the Calc-active Maths Methods exam. So question 5 and 6 being the multiple choice questions. As always, I'll invite you to attempt these questions first if you have not done so already, so please pause the video. And we will jump right into it after you've given these questions a crack. So question 5, the graph of the function f of d spanning the real field, f of x is equal to 3x plus 2 divided by 5 minus x, where d is the maximal domain, has asymptotes, and we've got options A through E here. So D here is the maximal domain, so there's no additional restrictions on this function. All you need to know is that, no restrictions. It's the implied domain that this function would normally have. Cool, so the difficulty with seeing the asymptotes when it's in this form, we can still see where the vertical asymptote is. We know if x was equal to 5, then we'd have 0 in the denominator. So therefore, that's obviously not possible. So that sort of tells us straight away that the x asymptote is at x is equal to 5. So we can immediately rule out A, B, and C. We can say x is equal to 5 and x is equal to 5. So how do we work out the y asymptote? Well, it's next to impossible to work out the y asymptote when it's in this form here. So what we need to do is rearrange the form. There's a couple ways you can go about doing this. The old trusty way that I used to do was long division. So I would take 3x plus 2 and divide that by what we're dividing in. So in this case, we have to change the order, minus x plus 5. We can see minus x goes into 3x minus 3 times. Expand that out. Hopefully you guys are okay with your long division. You get 3x minus 15. We know that there's a minus here, so we get 0. Plus 2 minus 15 is plus 17. So what we have is we have minus 3 plus 17 as a remainder. So 17 over that minus x plus 5, or that 5 minus x, like that. So when it's in this form, it's a lot easier to then immediately see what the other asymptote is. The other asymptote, we know it's been translated 3 units down, so we know that y is equal to minus 3. So that, therefore, that's this option here, so we know the answer will be E. If you're not confident in doing that by hand, there is a function on the calculator. The function's called prop_frac. So if you take prop_frac of f of x as it's defined over here, so it'd be 3x plus 2 over 5 minus x, what the calculator gives you is minus 17 x minus 5 minus 3. So slightly different form. They've just sort of rearranged the minus terms here, but the key thing again is identifying that the y asymptote is going to be translated 3 units downwards, so that would be minus 3. So something to keep in mind there. Great, moving on to question 6. So question 6 here, I'll just zoom in a little bit. Part of the graph of y is equal to f dash of x is shown below. So straight away we know this is the derivative function, or the gradient function. The corresponding part of the graph of y is equal to f of x is best represented by, and we've got options A through E. So we're given the derivative, and we want to work out what the original function is. So what's the easiest way to work this out? So I like to start with these 2 points here. Oops. Here and here. So we know at these 2 points, the derivative is equal to 0, right? We've got x solutions, so the derivative is equal to 0. And we know when the derivative is equal to 0, that translates to local minimums or local maximums. So trying to line it up, those are the only 2 locations where we've got stationary points. So looking through these functions, here we've got a stationary point, here's the other one, so we know straight away it can't be A. We know here's a stationary point, here's a stationary point, can't be C. Here we've got 3 stationary points, can't be E. B, we've got 1 stationary point and a second stationary point, and they look to be in the right positions. And D, we've got 2 stationary points, but on the right side. So it can't be D either. So that just leaves us with B, based on the stationary points alone. So that's a pretty nice and effective way of working it out. If there was other closer solutions and you need to provide a bit more detail, then what I would do is recognize that between these 2 stationary points, the function f dash of x is below the x-axis, meaning it's negative, right? So we've got a negative gradient here. Everywhere else, it's positive. So positive, positive gradient, positive, as it gets really positive over here. That's all positive. So now if we look at this function here, between the 2 stationary points, we've got negative gradient, and everywhere else is positive. So that lines up as well. So that's another way we can double check it. So not too difficult if you know what to look out for. The examiner's report had question 5 listed as 83% of people correctly choosing E. So pretty good overall. Question 6 on the other hand had 61% choosing B. The most common mistake was A with close to 20%, there you can see 19. So I guess most people probably just guessed A and didn't work through. So yeah, not too sure why people chose A in that case, but those are the steps. Hopefully, start with the stationary points, recognize whether gradient is positive and negative, and try to line that up with these options here. So if you found the video useful, then please give it a thumbs up and share it with friends or classmates. If you're new to the channel, then please subscribe for more videos like this in the future. And lastly, if you've got any specific questions you'd like answered, whether that's from a school practice test or a school exam or another past VCAA question, then please send me an email. Email's up on screen, and I'll answer it in another video. Thanks for watching. See you next time.